Yo! So, a bit later than I'd like because the Windows API was beating me over the head with type confusion and 40 different functions that all supposedly do the exact same thing but are slightly different, but we made it. I changed things up planning-wise a bit since the last time, so we're not in the exact place I had planned, but we got some netcom stuff going and we're in a fairly decent place to do some basic reversing. So, what's new then? Well, first off, I did the skid thing that I knew I'd have to do at some point and named my malware.
You still got it?
What one?
My sword. Needle.
Needle. Of course you named your sword.
Lots of people name their swords.
Lots of cunts.
So the malware's name is Wolf. Like the animal, but with a U instead of an O. Don't ask why, it just hit me ages ago and now that's what it's named. What I decided to do with Wolf was break it into two pieces. The main bit we've been developing on is basically going to be the dropper. It hits the system and eventually will pull the next part, the second stage payload, down to the system. At the moment, it's not working as a dropper, but it will be by the next video. I just couldn't really bother. Right now, I'm just executing the second stage manually. We'll call the first stage Wolf Dropper and the second stage Wolf Comms. The biggest thing that Wolf Dropper does is write check-in to a hard-coded registry key. Wolf Comms will check that predefined registry key every 5 seconds, and will read whatever data is in it and send it to the C2 server. At the moment, the C2 server just receives it, and that's it. But with the check-in value, that's going to be what signals to the C2 that a new host has been added. What this allows us to do is basically modularize our malware going forward. Instead of having a bunch of different pieces all within one executable, we can have several disparate pieces that are way smaller. Wolf Comms is about 13 kilobytes at the time of writing, and Wolf Dropper is 12 kilobytes. So we keep the file size down, we separate all the complex pieces out and organize them better, and we make it easier to create new modules because with this design, all they have to do is do whatever their function is, and when the time comes that they need to communicate with the C2, they write to a given registry key and Wolf Comms will automatically send it to the C2. There are some glaring issues with this design. Like, what happens if multiple components try to write to a key at once, or if the value gets appended and confuses the C2? Luckily, I have a very simple solution to that problem. Just kick that can down the road and let us deal with it later. Now let's get to reversing. Alright, welcome back everybody. So now we're going to do some very simple reversing. And I only say very simple not because it's not important, because we're actually going to build out a YARA rule that is fairly good for detecting both our dropper and our netcoms library. I say very simple because you can actually do a fair bit of reverse engineering, at least on the very, very basic level, without ever opening up IDA or Ghidra or looking at any assembly or anything like that. We're going to do the very, very simple work here, and then once our malware gets a little bit more advanced, we're going to start moving into the more advanced stuff. So let's get started. So let me look at our directory listing here. We've got both our comms exe and our dropper exe right here. This is the YARA rule that we're going to be marching through here in a second, but let's not worry about that right now. Let's do the very basics, and whenever I'm actually doing any kind of reverse engineering, I always start with strings, because you can actually get some fairly interesting information out of that. So what we're going to do is let's do strings wolf underscore dropper.exe, and we're going to put that out to wolf dropper strings.txt. And let's do the exact same thing for wolf underscore comms.exe, and we're going to output it to wolf underscore comms underscore strings.txt. I'm just outputting it to a text file because that'll make it a little bit easier to read. So let's open that up. Let's go to our desktop, then RRE9, and we see both of our strings files right here. So let's open up our dropper strings file first. If we expand this, then we can see, let me actually make this a little bit bigger. So we can see our strings here. These are all of the ASCII strings that are in the file. This can actually tell you some really, really interesting information just right off the bat. So up here at the top, we can see this program cannot be run in DOS mode. That tells us right off the bat that we're dealing with a PE file. If we didn't know anything else about the malware, now we know that it runs on Windows and it's a PE file. So that tells us a lot of information just right off the bat too. We've got our .text segments, our data segments, and all of this information, not super useful, but if we scroll down a little bit more, we can actually see some more interesting information. We've got wolf/comms here. We don't necessarily know what that means. That could be a file location, that could be a registry key, we're not entirely sure. We've got debug window, got the length, did the write, successfully wrote to the registry key. We've got an error message here. We've got the string check-in, and then we've got a PDB. Now a PDB basically is some debugging information that is left within executables sometimes that can give you a lot of information about the environment that it was developed under. So as we can see the development system's username, we've got the location of the build file, we've got the actual name of the malware. So like I said earlier, I named it Wolf. So we've got a lot of very useful information here. We've also got the fact that it's an x64 and the release version of the x64 build. So just really without doing anything more than running one command, we've got some very interesting and useful information. If we scroll down a little bit more, not too much else. We've got message box A, that's going to tell us we're dealing with message boxes within this file. We've got reg set value A and reg create key XA. So that tells us right here that we're going to be dealing with some registry keys, which, once we actually do open up Ghidra and IDA, or if we look at we're going to look at process monitor here in a second. That's obviously going to be very interesting and very useful for us to know. So if we scroll down, there's not too much more. We've got get current process ID, get current thread ID. Useful, but not necessarily the most useful thing. If I'm looking at this file right now, just right off the bat, obviously reg set key and reg create key, obviously very useful information that tells us, some about the functionality of the malware before we even open it up. We've got the PDB, which would be very, very useful for tracking this later on. Basically, you would use this to kind of track personas and things like that. So now we know the username of the, probable malware author there. We've got successfully wrote to the registry key written out here as a debug string. So that tells us more about the fact that, we are doing some registry key writes. And we've got this wolf/com string. Now this is useful mainly because it's a very unique string. What we're looking for with YARA rules especially is unique strings that we can use to detect malware and minimize false positives. So if we've got a very, very unique string that isn't likely to be in any files that are not malware, that can be very, very useful for us. Strings like, for example, .text, that is a string that you're going to find in basically every PE file. This program cannot be run in DOS mode. That's going to be in every non-obfuscated PE file. So it's not going to be very useful for YARA rules. So that's our dropper. Let's open up our comms strings. So if we open this up, we've got the same exact thing, the DOS stub right up here. We've got .text, so that kind of confirms that we're dealing with another PE file. We're not dealing with a DLL or anything like that. If we scroll down a ways more, we find that same exact string, wolf/comms. We find the word yeet, which is another unique string that you're not likely to find in many other executables. And then we've got something very interesting. We start to see some IP data here. So this post/fic down here, we can see this line right here probably corresponds to an HTTP request, a post request to the /vic directory. We've got a host string right here that tells us we might need to look for a network connection to this IP address with that port. We've got a specific user agent that can be useful both in static detection using YARA and in dynamic detection on the network. So that can be incredibly useful for us if we're looking for specific user agents right here in this specific host as well. So these are all headers that you're going to find within an HTTP request. Then you've got this message. This looks like the beginning of a JSON object. So that's going to be super useful for us. We're looking for JSON data that's leaving our network more than likely. So that obviously is something we want to keep around. We've got debug window, get address info failed. So this tells us a little bit more. We're looking for a connection to be created because get address info is an API call for the WinSox library. Error in creating socket tells us a little bit more. Socket connection error. Those are all pieces of information that basically tell us that we're dealing with something that is going to, in fact, try to create a network connection. We've got entered while, that's another debug string. And then we've got an IP and a 4-digit number. So this IP address right here, obviously it's local because I'm testing all of this locally. But this IP address right here, I would want to record and look for in dynamic detection or in running it dynamically so that I can like look for, potential communications with a C2 address. This right here, it might just be a random 4-digit number, but because it's right after this IP address and all of this is parsed sequentially in memory or in the actual binary file, then I'm going to assume that this right here is a port. It's also a valid port. So, port 9998 is a valid port. So that might be something that we want to look for. We've also got regval, which is not something that is typically within, a normal binary. I'm going to assume that that is the name of a variable that holds a registry value. And we've got a PDB here. So obviously we've got the same persona that can be used to basically tie together one sample to another. So we've got our wolf comms object here, or wolf comms executable here, and we looked at the dropper earlier. This would confirm to me that the two are related. Basically that they are both developed with the same PDB, or at least the same username on, in the PDB string. So if we scroll down a little bit more, we're not going to find too much else other than that, but we've got a lot of very useful information. We can also see the exact same libraries here, reg query value A and reg create key XA. That tells me a little bit more that it's going to be, reading and or writing to the registry on the system. So all very, very interesting and useful information that, I would want to make note of if I were actually reversing this. So let's move on to a little bit of dynamic reverse engineering. All right, so if we've got Procmon open here, we can immediately see that there's just tons and tons of results. This is what you're going to see as soon as you open up Procmon. So as we can see at the bottom, we're dealing with over 100,000 results within Process Monitor. And what Process Monitor does is it basically looks for all changes to the system. We're talking about reading from files, writing files, closing files. We've got registry changes. We've got all of the TCP/IP connections. Basically everything that happens on the system is going to be recorded within Process Monitor. That's not necessarily good or interesting for us, but it does show us basically how busy the Windows operating system is. Right off the bat, what I like to do is create a filter. And what we're going to do is filter on the process name. We're going to say it contains the string wolf. And we're going to say if it contains a string, if the process name contains a string wolf, then we're going to add that to the window pane that we're looking at right now. So I'm going to apply this filter, press OK, and as we can see, nothing is happening because as of right now, our malware is not running. So let's go ahead and run the dropper. And we see these debug windows showing up. This is the debug version of the malware. So I've got tons and tons of debug windows. And then let's run the comms object on its own. So same thing here, and we're going to let it run through twice. Basically all this does is it waits 5 seconds and then it sends the same check-in value to the C2 server. So that's what it's doing right now. All right, so let's exit the two. We've already exited out, so these aren't going to run again, and we can see 1,700 different items within this pane that our malware created. Every single item within this pane is another activity, basically, that our malware took part in. Not all of them are useful. In fact, most of them are not useful. We're actually going to have to look through a bunch of crap that isn't necessarily useful in order to find the stuff that we do actually care about. So just because I've done this before to kind of speed up the video a little bit, let's go ahead and look up reg set, and that's going to show us basically places where our process actually set a registry key. Now, this is actually fairly noisy. There are a lot of perfectly normal instances where your process is going to mess with the registry. So we're going to have to search around a little bit for something useful. In fact, that I think is a fonts related registry key. Not super useful for us. We're going to keep looking. Same thing there. That's a language pack related registry key. As you can see, tons and tons of data in here. Language packs again. And now we start to get to the HKLM, which I can't remember exactly what that does. It's the H key local something, I believe. So let's keep on parsing through here. Local settings, not necessarily useful. Now we see something useful. This line right here. HKCU is the H key current user, so that is whatever user is logged in and running this process, /wolf/comms. Now, if you remember back to the portion where we were running through the strings data, that wolf/comms piece of information was actually a string that was in our files that we were looking at. So now we can see it wasn't a file location. We're talking about a registry key that we're setting here. It actually tells us what we're setting it to. We're setting it to check in. If we looked at those debug boxes that popped up, check-in was one of the items that popped up. Obviously, that's not going to happen with real malware, but you might see it, in fact, in the actual network data. We're not going to go through the network data here, but you might see it in the network data that it's sending the value check-in with its communications with the C2. So here we've got this wolf/comms registry key being set. Obviously very interesting information that we are going to want to keep track of, and we can actually see that within regedit. If we open up registry editor, we can see that right here. I already have it open because I was running through this earlier, and we can see that the wolf/comms default value was set to check in. So again, useful information that we're going to want to make note of. Now let's start looking at the network data. So if we go back to our strings, let's go to desktop and RRE9. And we're going to open up, I'm actually going to need to do this in a text editor. Let's go to wolf_dropper.strings or underscore strings. I believe it's in that. 192, nope. So it is in the communications executable right here. So let's look for that IP address and let's see exactly what it's doing with this IP address. We've got one IP there. Let's go ahead and copy and paste that and see if we can find it within our process monitor. So let's search. So we're looking for it. And it may not end up finding it actually. Yeah, so it didn't find that IP. So that IP may not be the true C2 file. Let's find the next instance of 192. So here we actually find it. So let's search for that IP address and let's see if we find it in our procmon. And it appears that we did. So we've got a TCP connect instance, a TCP send instance, a TCP receive instance. So this is basically showing that we have a full communication, basically a full conversation between this C2 and our victim box. So it is in fact a port 9998 communication. We've got the length of the data that's sent. I don't believe it actually shows the raw data. I think you have to look at that through something like Wireshark or TCP dump. But still, it shows us that we are in fact communicating with that server. We can assume that that's probably going to end up being a C2 server. So, as you can see, we've got a lot of very interesting and useful information. In fact, I'm going to show you here in a second that we've got enough information to write a YARA rule. So let's go ahead and open up the YARA rule that I've already created. And it will be an RRE9. And wolf_dropper.yar. We're going to open with our text editor. Oh, gracious. Let's see. Okay, that opens it up in Firefox for whatever reason. I guess we can view it like this, but we're going to use Notepad. Let's do notepad.exe, and I think it's wolf_dropper.yar. There we go. So we've got it open in Notepad now, and we've got, just some fairly normal information. I actually had a mistake there. We've got to add an extra backslash, but this is a very, very basic YARA rule. We've got the keyword rule followed by the rule name, wolf_dropper. We've got some meta information. The author, Viking_sec. You would normally want to put, your actual name there, or just any name that somebody can use to find you on the internet and ask you about your rule. Then we've got a description, wolf_dropper detection, please subscribe. Obviously, in real instances, you would want to be a little bit more verbose here. Then we've got a list of strings. So each string variable name is started with a $, and then the name of the actual variable itself, and then the value that you're looking for. Basically, what this is going to do is it's going to parse through all of the files within a given directory and look for these strings. So if it finds those strings, then it's going to basically alert on that rule. So we've got the keyword yeets, we've got this C2 address right here, and then we've got wolf/comms. So those are the three basically most unique strings within the binary, the binary executables that we were looking at. And after that, we're going to say, here are our conditions. We want all of those strings to be found within a file in order for us to alert with this rule. So let's go ahead and run that. We're going to do, I think it's located in Z, RE_tools/YARA 64.exe. We are going to run it with the wolf_dropper.yar rule, and we are going to run it on this entire directory. So it's C, users, Viking, /desktop/RE9. And let's run it on the full directory. Wolf_dropper. There's a syntax error on line 3. Oh, it's author equals and description equals. I don't know why I screwed that up. That's weird. And there's another one on line 9. So that's 3, 4, 5, 6, 7, 8, 9. Conditions. That's weird. Oh, duh. So it's condition, not conditions. So let's go back down to this line and erase the S. Now we should be good to go. So let's clear out, run it, and here we've got our heads. So it runs on wolf_comms_strings.txt and wolf_comms.exe. So we see that it actually doesn't hit on our dropper. And the reason why is I don't believe our dropper had the yeet string or the C2 string. So if we get rid of these two, I'm betting you that it's going to run on both. So let's save this, run it, and yeah, it runs on both. So we've got the wolf comms and we've got the wolf dropper. Now, you don't necessarily want to, do it the way that we just did it. We may want to make it as strict as humanly possible and call this rule wolf_comms. And then we're going to create a second rule within the rule set now. And, well, if I can highlight it, there we go. And basically what we're going to do then is, now that we've got, two different rules, then they're going to trigger on two different things. So wolf_dropper is going to be this one. And it's just going to have yeet and C2 taken out. And it's just going to have wolf/comms. Now the problem with this now is, now that we run this, we're actually going to trigger on comms twice. It's going to basically trigger on comms once with the wolf_comms rule, and it's going to trigger on comms once with the wolf_dropper rule, because the wolf_dropper rule is the exact same rule but less specific. So now is when you kind of get into how do I create good rules and good rule sets. And that's a little bit more advanced for this video. But now we have a good way to actually detect whether or not this malware has been dropped on the system, to detect whether or not the malware that we're looking at is in fact the wolf dropper or the wolf comms. And it's a way that we can actually upload this rule set to VirusTotal and other, malware platforms and hunt for new samples of this malware. So that's really it for the beginner kind of reverse engineer. We're going to get into the assembly and a lot of the weeds later on, but it's good that we kind of start here as kind of a baseline. Later on, once we get into the assembly, we're going to talk about better ways to create YARA rules, better ways to hunt, things like that. But This is kind of a good start. And now you've got a great way to detect the wolf first and second stage. Real reversing with real malware is obviously rarely this easy. I got to develop YARA rules with the source code right in front of me, and there were unique strings in clear text that made it pretty easy to write rules with. I will not ever say that this is the typical way that you would reverse real malware. So what's next then? Well, we've got to make a dropper the actual dropper. My plan there is to just stick the second stage in a directory that's accessible by the C2 and have the first stage fetch the raw bytes and write them to a file before executing them. Nothing fancy necessarily, but it's one way to do it. Later on, we'll encrypt the second stage and have the first stage decrypt it, but not right now. That's a little too complicated. After that, I think I'll write a simple information gathering mechanism that will gather information about the system and send it off to the C2. Network information, user and OS information, all of that kind of stuff. I'll do some good heavy lifting on the C2 backend to make it actually store that information and display it as well. After that, I think I'm going to write some basic obfuscation to make things a little more interesting on the reversing side before we start to look at some of the more advanced reverse engineering. I'll probably add a little bit of command and control and actual commands so that it actually does something once it's on the system. Thanks all so much for the awesome support between this series blowing up and my cybersecurity startup devlog doing well. It's been awesome to see all of the people getting excited about the research I'm doing. Until next time, peace.